Understand the physical system and equilibrium equations. Each of the three beakers contains water and a solid lead salt in contact with its saturated solution. These represent heterogeneous solubility equilibria, which can be written as Beaker 1, PbOH, 2 is in equilibrium with Pb to the power 2 plus 2 OH to the power negative Beaker 2. PbI2 is in equilibrium with Pb to the power 2 plus 2 I to the power negative Beaker 3. PbF2 is in equilibrium with Pb to the power 2 plus 2 F to the power negative. Formulate the solubility product constant, KSP, expressions. All three salts share the exact same stoichiometry, having a formula of the type XY2 where 1 mole of solid dissolves to yield 1 mole of lead cations, Pb to the power 2 plus, and 2 moles of anions. Because they have identical stoichiometry, they share the same mathematical form for their KSP expressions. KSP equals Pb to the power 2 plus, anion to the power negative, to the power 2 if we define the molar solubility of each salt as S, then at equilibrium. Pb to the power 2 plus equals S, anion to the power negative, equals 2. Substituting these into the equilibrium expression gives KSP equals 2s to the power 2 equals 4s to the power 3. Therefore, S equals square root of KSP over 4. Compare molar solubilities using the given KSP values. Because all three salts share the same stoichiometry, their molar solubilities, and consequently, their equilibrium, Pb to the power 2 plus concentrations are directly proportional to their KSP values. A smaller KSP value mathematically guarantees a smaller molar solubility and a lower Pb to the power 2 plus concentration. Looking at the provided data table, KSP of PbOH 2 equals math 1.2 times 10 to the power minus 15 Kelvin. Sp of PbI2 is equal to 1.4 times 10 to the power minus 8 Kelvin. Sp of PbF2 is equal to 4.0 times 10 to the power minus 8. Comparing these values, the KSP of PbOH 2 is 7 orders of magnitude smaller than the other two constants. 1.2 times 10 to the power minus 15 LL 1.4 times 10 to the power minus 8 less than 4.0 times 10 to the power minus 8. Conclude, because PbOH 2 has by far the smallest solubility product constant, it dissolves to the least extent. It will therefore yield the lowest equilibrium concentration of lead ions, Pb to the power 2 plus, among the three systems, making option A the correct answer. The correct answer is option A, PbOH 2.